Next, we're going to talk about air pressure. And you may have heard about air pressure when you're listening to the news and people are talking about the weatherman might be or weatherwoman might be talking about storms approaching, and they often talk about the change in air pressure as a result of weather systems. So just to talk about the very basics of air pressure, first we're going to say, what is air pressure? Air pressure is the force of all of the gas molecules in air, or atoms if it's depending on what it is. So atoms and molecules that are in the atmosphere, they're exerting a pressure as they move in random directions and they impact surfaces. So you can think of a balloon. When you blow up a balloon, it's full of air particles, gas molecules, and they're each exerting a force. And as they hit the sides of the balloon, that's what's holding the balloon into the shape that it is. You can change air pressure by either increasing or decreasing the number of atoms or molecules in a space, or you can increase or decrease the temperature of that space, and that in turn decreases or increases the velocity of the particles. So as particles have more energy, as you heat them up, they're going to move more quickly. We measure air pressure in units of pascals or millibars. 1 pascal is equal to 0.01 millibars, and so those are the units of measurement you'll hear when people refer to air pressure. More often, you'll probably hear of pascals, but you do hear both. So we discussed before when we talked about the layers of the atmosphere that gases are held to Earth by the Earth's gravitational pull, and because of the way it's pulling on these molecules, you're going to have a higher density of gas molecules closer to Earth's surface as you get away from Earth's surface. So as you travel up in altitude, you're going to have a lower density of gas molecules. Another effect that we see that increases air pressure is that in the troposphere, temperature decreases as distance from Earth's surface increases. So again, as you travel up in altitude or distance away from Earth's surface, the temperature decreases. So both of these act in unison to cause the same result, which is that air pressure decreases as you increase in altitude. So if you go to the top of a mountain, such as Mount Denali in Alaska, when you're at the top, you're going to notice that the air pressure is lower, and that's because of two factors. One, you're up high, a farther distance from Earth's surface, so there's a lower density of gas molecules, and also the temperature is lower. It's very cold up there.